This video is on solving quadratic equations with all three terms. So just as a recap, in our last video we talked about how a quadratic equation will always be of the form ax squared plus bx plus c. And we talked about the fact that a can't ever equal 0, because if a equals 0 we won't have a quadratic equation. But b can sometimes equal 0 and c can sometimes equal 0, and we looked at those sorts of equations. In this video, a, b and c will not be equal to 0, so we are going to have three terms for all of the quadratic equations we're about to look at, three terms. And what you need to understand is that this equation will have three terms, and the only method we're going to use to solve these equations is you must factorize them. Okay, so you're going to factorize to solve these quadratic equations. In our last video, we factorized one set of equations, but the others, the ones where b equals 0, when b equals 0, for example, 4x squared minus 16 equals 0, that's where we don't have a b term. With those, you could actually move all your terms to one side and make x squared the subject, and then you can square root both sides and get plus minus 2. So those actually don't need to be factorized. So every now and then you can get equations that don't need to be factorized, but most quadratic equations you will have to factorize. So let's have a look at them. Hopefully your factorization skills are good, because they will need to be to solve quadratic equations. These are quadratic trinomials, so that means we're going to need double brackets. And this is the method I use, where I just basically place all the terms inside. So I put my starters in, that would be f and f, and then I'm going to think of two numbers that multiply to give 24 but add to give minus 11. And hopefully you can already see that 8 threes are 24. And to get a negative 11, I would need a minus 8 and a minus 3. And I talked about in one of my previous videos doing an outside-inside check at always making sure. So f times minus 8, that is minus 8f. And minus 3 times f is minus 3f, and that does give me minus 11f, which is what I want in the middle. The reason why I don't check these two terms is because in setting up the brackets, I've already done them. So f times f, I already did that straight away to get the first term before I put down any other terms. And then I tried to come up with two numbers that multiply to give 24. So the 3 and the 8 I've already done. So really the crucial term to be checking for is minus 11f. That's very, very important. Okay. Now, we're not done. We're now ready to apply the null law factor, which says if you've got two expressions that multiply to give 0, well then one or both of them must be 0. So f minus 3 has to equal 0, or f minus 8 equals 0, and that gives me f equals 3 and f equals 8. So let's factorize again. This time I'm going to open up my double brackets. Don't drop your equal sign. The starters would have to be p and p, and I need two numbers that multiply to give 45 and add to give minus 4. Notice I don't worry about the minus. I do need them to multiply to give minus 45, but I'll worry about that right at the end. So just 45, or I'm thinking about 15 and 3, but straight away I realise with 15 and 3 I can't get minus 4p. So what about 9 and 5? 9 and 5 sounds like it'll work much better. So if I put down 9 and 5, to get this minus 4, the sign here is very important that you think about that. I will need a minus 9 and I'll need a plus 5. And then from here I can apply my null law factor, which says that p minus 9 would have to equal 0, or p plus 5. Oops, a bit messy. P plus 5 would have to equal 0, and that gives me p is 9, or p equals minus 5. Right, our last example, let's factorize again. Hopefully your factorizing is getting good, but there's one thing you want to notice, and that's that this term is not on the right side. It needs to be with the other terms over here. So what I'm going to do is minus the 15, and so I get all three terms on one side. And then I'm ready to open up my brackets, and my starters would have to be y and y, and I want two numbers that multiply to give 15, minus 15, and add to give 2. But like I said before, I'll worry about the minus 15 later. Let's just do 15 because it bogs my brain down less. So 15, I can straight away see that 5 3s are 15, and I chose 5 3s because they have a gap of 2. So to get a positive 2, I really want to do positive 5y, and then I want a minus 3. So just check that with an outside-inside check. So these two, I put the positive because I want the 5y term to be positive, and I put this minus here because I want the 3y term to be the subtracting term. And then when I multiply them, I can see minus 3 times y is minus 3y, and 5 times y is positive 5y, and that does give me my middle term of 2y. So this check, hugely important that you don't skip doing a check like this and making sure you're right, because if you factorize it incorrectly, the whole equation will be, your whole solution, will be wrong. So the factorizing part is very important. So let's use our null law factor now, which says that y plus 5 should equal 0, or y minus 3 can equal 0. At some point you probably won't need to even write y minus 3 equals 0 and y plus 5 equals 0, but at the beginning I think that's very important. And we get y equals minus 5 and y equals 3. Alright, so the only kind that we need to look at, I guess, would be the non-monic kind. So these are going to be a little bit trickier, but, with practice makes perfect. So here we've got a prime number at the start, so my starters would have to be 3t and t. And then I need two numbers that multiply to give 2, and hopefully you're getting a bit more strategic, because I can see straight away that, especially if you draw these brackets in, you really start thinking in a certain way that I need a 2 here, because that'll give me 6t. And that means I need a 1 here, because 2 times 1 is 2. And that'll give me plus a t, and that will give me the 7t that I need. So that actually works really well. So I want everything to be positive, because I want a plus 6 plus a 1. And then I'll just apply my null law factor, which says 3t plus 1 would have to be 0, or t plus 2 equals 0. And that gives me 3t equals minus 1, and t equals minus a third. And then we'd get t equals minus 2. 2 more to go. Let's open up our brackets. This one's a bit trickier, because to get 10a squared, I could actually do 10a and a, or 5a and 2a. I'm actually going to go the 5a and 2a, because I have found with my experience it's better to do the smaller factors, unless you can see an obvious connection. I could be wrong. But also, like I said before, we're trying to be strategic with where we place numbers down. So straight away, I know I'm trying to get a 9a. So what I've realized is, this is a good one, I nearly just placed my numbers in the wrong place. I'll show you what I was about to do. I was about to say, well, I want to put a 2 here and a 1, because I know that 5 2s are 10a, and then minus 2. Well, that doesn't even work. So who knows what I'm thinking, maybe because it's late at night. So let's undo all that. You can always change your mind. You can always swap things around. I'm now going to put the 2 here and put the 1 there, because as I was about to make my mistake, I realized it. So if I multiply the outsides, I get 5a times 1. And if I multiply the 2a by the 2, I get a positive 4a. And that does, in fact, give me 9a. So I want this to be positive. I want that to be positive. So I get 5a plus 4a, which equals the 9a. And so now I know that I factorized correctly. It's straight into the null law factor, which says if these are being multiplied, the only way to get 0 is if the first expression equals 0, or the second expression equals 0, or both equals 0. So we're going to get minus 2, a equals minus 2/5. I would write this out, because students, and myself included, makes pretty easy to make simple errors when you're tired or you're rushing. So just take the care and get it right. You'd rather go slowly and take the extra lines than be missing a minus sign in the final line. All right, last question of the video. Hang in there with me. So we've got, once again, slightly trickier, because with 4k squared, it could be 2k and 2k, or 4k and 4k and k. I'm actually going to do the 4k and k, because like I said before, you should be thinking strategically about where to place the numbers. And as soon as I see this 21k, my brain's already thinking, well, 4 5s are 20. So I'm feeling like putting a 5 there to get the 20, and putting a 1 here. So if I multiply out my inside-outside brackets, I get 20k, and I get plus another k, and that's exactly what I want. But now I have to think about this minus, and the way I'm going to get around that is, I know that if I have minus 20 minus 1k, minus 20k minus 1k, I will get minus 21k. So that's the way I'm going to go. I'm going to put a minus here, and I'm going to put a minus there as well. And now I know that I've done this correctly. So now we can just apply our null law factor, which says that 4k minus 1 equals 0, which give me 4k equals 1 and k equals a quarter. Or I could get k minus 5 equals 0, which means that k must equal 5. So the good thing about solving quadratic equations where you have all three terms is the method is fixed. Factorize the quadratic, apply the null law factor. I hope this video makes it clearer to you.